Hi, I'm Tarik.
And I'm Jeffrey. For our CS205 final project, we developed a simulation engine for a multicellular colony, and we tried to come up with a parallel update mechanism to speed up the simulation.
Within the broader context, we try to develop techniques for n-body simulations where the interactions are only between local neighbors. Here we assume that the cells are circular bodies and their volumes are growing exponentially. Each of the cells divide into two cells after it reaches a threshold radius, which is sampled from a Gaussian distribution. Each of the cells exert force to its neighboring cells, and that way the cells displace one another from their places.
The naive serial approach we compare as the baseline takes all possible pairs of cells, so has a time complexity of big O of n squared, where n is the total number of cells. However, the parallel implementation speeds this computation substantially. We used MPI scatter and gather method to implement the divide and conquer method. As we can see, we have drastic speed up as we increase the number of processes, and the efficiency converges to about 30%. If we increase the problem size while keeping the number of processes constant, the efficiency increases dramatically, showing that we have both weak scaling and that this problem is compute bound.
We try to use BFS algorithm to find all the neighbors more efficiently because we assume that the average number of neighboring cells would be small, and that is true in the beginning stage and it showed substantial improvement. However, when we had a lot more overlapping cells in the later temporal stage, the calculation reached big O of n squared in terms of time complexity. So these become substantially slower than the original naive approach due to the extra calculations.
So we did not implement BFS in parallel because it showed no performance gain over the naive approach. We are now working on a different method where we divide up the simulation space into several grids where each process is responsible for handling a subset of all the cells within a certain region. We hope that this will reduce the number of comparisons and will speed up the simulation.
Thanks for your time.
Thank you.